The National Fire Protection Agency, or NFPA, mandates specific cubic inch space requirements within junction, receptacle, metallic, and non-metallic boxes, primarily to facilitate adequate heat dissipation and, consequently, prevent overheating. When electrical conductors are packed too tightly inside an enclosure, their collective resistance to the flow of electrical current generates heat. This heat, if not properly managed, can escalate to dangerous levels, potentially damaging the insulation surrounding the conductors. Damaged insulation compromises the integrity of the electrical system, increasing the risk of short circuits, arcing faults, and ultimately, electrical fires. The specific cubic inch space mandated isn't a one-size-fits-all figure. It is determined by several factors, including firstly, the quantity of conductors present within the box, secondly, the physical size or gauge of those conductors, thirdly, the type of box being utilized, for example, whether it's a standard junction box, or a receptacle box, or a specialized enclosure, and fourthly, the material from which the box is constructed, for instance, whether it is metallic, non-metallic, or a hybrid construction. To provide definitive guidance on these requirements, the NFPA publishes NFPA 70, which is more commonly known as the National Electrical Code, or NEC. The NEC contains detailed tables and calculations that dictate the minimum allowable box volume based on the aforementioned factors. These calculations consider the cumulative volume occupied by the conductors themselves, any splices or terminations made within the box, and any internal devices such as receptacles or switches that contribute to the overall fill. For instance, the NEC stipulates that a box must possess a minimum volume of 2 cubic inches for each individual conductor present. This 2 cubic inch per conductor rule serves as a baseline, ensuring sufficient space for basic wiring configurations. However, the code recognizes that additional space is often required to accommodate more complex wiring scenarios. For example, when splices or bends are introduced into the conductors within the box, they consume additional volume and impede airflow. Therefore, the NEC mandates an increase in the total required box volume to account for these factors. Specifically, for boxes containing multiple conductors, the total volume must be increased by 25% for each additional conductor beyond a certain threshold. This incremental increase ensures that even in densely wired boxes, there is still adequate space for heat dissipation and safe conductor manipulation. Furthermore, the NEC places emphasis on proper conductor termination. It mandates that boxes must be of sufficient size to allow for the safe and effective termination of conductors. Conductors must be able to be bent to a radius that is at least 10 times the conductor's diameter without stressing the insulation or compromising the integrity of the connection. This requirement is crucial for preventing premature conductor failure and ensuring long-term reliability of the electrical system. The NEC also addresses the space requirements for splicing conductors. Splicing involves joining 2 or more conductors together to create a continuous electrical path. This process requires sufficient space within the box to accommodate the physical dimensions of the splice connectors such as wire nuts, crimp connectors, or terminal blocks. The NEC mandates that boxes must provide enough space to allow for the safe and secure splicing of conductors, ensuring that the connections are mechanically sound and electrically continuous. Failing to adhere to these cubic inch space requirements can have severe consequences. Overcrowding conductors in an undersized box restricts airflow, leading to a buildup of heat. This elevated temperature can degrade the insulation surrounding the conductors, causing it to become brittle, cracked, and ineffective. Compromised insulation exposes the bare conductors, increasing the risk of short circuits and ground faults. A short circuit occurs when 2 conductors with different voltage potentials come into direct contact, resulting in a sudden and uncontrolled flow of current. This surge of current generates intense heat, which can ignite nearby combustible materials, leading to a fire. A ground fault occurs when a conductor comes into contact with a grounded surface, such as a metal enclosure or a water pipe. This creates a path for current to flow through the grounding system, potentially causing electrical shock hazards. In addition to the risk of fire and electrical shock, overcrowding conductors in electrical boxes can also lead to equipment damage and malfunction. The excessive heat generated by overcrowded conductors can damage sensitive electronic components such as circuit breakers, switches, and receptacles. This damage can lead to premature failure of the equipment, resulting in costly repairs and downtime. Furthermore, overcrowded conductors can impede the proper functioning of electrical devices. For example, if a receptacle is wired with conductors that are too tightly packed into the box, it may not be able to dissipate heat effectively. This can cause the receptacle to overheat, potentially damaging the internal contacts and rendering it unusable. Providing adequate cubic inch space in junction, receptacle, metallic, and non-metallic boxes is not merely a suggestion or a best practice, it is a fundamental safety measure mandated by the NEC and enforced by electrical inspectors. Adhering to these requirements helps to prevent fires, protect electrical equipment, and ensure the safety of people and property. It is the responsibility of electrical contractors, electricians, and homeowners to understand and comply with the cubic inch space requirements outlined in the NEC. By doing so, they can contribute to a safer and more reliable electrical system. In summary, the NEC dictates minimum box fill requirements to ensure electrical safety, to prevent overheating, and to allow for safe conductor manipulation and termination. These requirements are based on conductor size, number of conductors, box type and material. Compliance is crucial to prevent fires, equipment damage, and electrical shock hazards.